Good evening, everyone. Thank you for joining us tonight for the first installment of the University of Adelaide's Make History Speaker Series for 2023. This first installment tonight is entitled Writing History in the Stars, and to that end, we have assembled a star-studded panel to discuss my and your questions regarding space here tonight. So thanks for joining us. My name is John Colton. I'm the director of the Andy Thomas Center for Space Resources here at the University of Adelaide. We're located in the School of Architecture and Civil Engineering within our Science, Engineering, and Technology faculty. I'd like to start today's speaker series by acknowledging that the land we meet on today is the traditional land of the Kaurna people, and we respect their spiritual relationship with their country. We also acknowledge the Kaurna people as the traditional custodians of the Adelaide region, and that their cultural and heritage beliefs are still as important to the living Kaurna people today as in the past. It's now my pleasure to introduce tonight's panel members. Immediately to my left, Dr. Kimberley Clayfield is the director of CSIRO's Space Research Program, with oversight of the CSIRO Centre for Earth Observation and the AquaWatch Australia Mission. She is the leader of the CSIRO Space Technology Future Science Platform, a recipient of the university's James McWha Award of Excellence, and recognized in the Australian Space Discovery Centre on Lot 14. So I think we can give each one an individual round of applause. Thanks. Next up, Dr. Sarah Cannard is Senior Engineer and Project Manager with Nova Systems. She is also a Fellow with Engineers Australia, an Amelia Earhart Fellow, a graduate of the Australian Institute of Company Directors, and the Program Director and Project Manager for the Australian Remote Operations for Space and Earth, and an Industry Director at the SmartSat Cooperative Research Center. Welcome, Sarah.
Welcome.
And at the extreme left, Dr. Matthew Tetlow, the CEO of Innovor Technologies and a researcher in the University of Adelaide School of Electrical and Mechanical Engineering. In 2020, he was named Australian Space Innovator of the Year at the Australian Space Awards, and his nanosatellite company, Innovor Technologies, was named Australian Space Business of the Year. So welcome, Matt. Okay, so for this evening, we'll have about 45 minutes or so of questions that I'll ask our panelists. It's really going to be fairly broad ranging, so I'll ask a question, but we're going to have basically a conversation up here amongst ourselves, and we'll see where that goes. We'll wrap up the evening with questions from the public, and we'll have mics to go around the room to take your questions for our fantastic panel. So for the first question, Kimberley, I'll go to you. And I just ask, can you tell us a little bit about the history of CSIRO in space?
Sure, thanks very much. And hi, everybody. It's great to be here with you tonight. So I work for CSIRO, which is Australia's national science agency. We carry out science in a really broad range of areas, ranging from environment to energy, health and biosecurity. We've got a section called Data 61, which is our digital research team, and we also have a division that works in space and astronomy. But our history in space actually goes back more than 70 years. It really began with our radio-based science back around the time of World War II and developed through our radio astronomy activities. CSIRO operates the national radio astronomy facilities for Australia. Several decades ago, probably at least 40 years ago, we developed very strong capabilities in Earth observation science. So using imagery from satellites to better understand our Earth and climate and so on. So we do a lot of work in applications development and data analytics related to Earth observation. And then coming a bit closer to the present day, we are growing our activities related to space science and space exploration, and more applications and technologies that will support space activity. So I'm the director of our Space Research Program, and we're looking in areas ranging from satellite technologies to lunar exploration. We are looking at some space life sciences. We look at communications technologies, and that's just a few of the things that we're looking at. So it's a really exciting range of areas that we're working in now.
And we'll have opportunity to dive deeper into some of those things as we get further into the conversations tonight. So thank you, Kimberley. Sarah, I'd like to move on to you next and just ask, what was your pathway into the space sector?
Yeah, sure. So, yeah, thanks. So my pathway has been fully sovereign. A lot of people that end up being in space, particularly when we went through university, needed to leave Australia in order to pursue that space career. We did activities in space, as Kim has already mentioned. We've got a very long space history, but we didn't have a strong, coherent space sector, not until the Space Agency was really born in around about 2018. So back when I was at school and at university, I went to Adelaide University, a mechanical engineering degree, science, and a PhD in aerospace. The closest thing I could work on in space was in defence. And so I was always had the inclination or the desire that eventually I'll go overseas if I want to work in space. But in actual fact, and it's not very well known, but as well as what Kim has been talking about, but defence has been doing some amazing work in the space sector for a long time, including suborbital hypersonic rocket launches. So I was involved in a couple of those. We're involved in the Hayabusa 1 and 2 re-entry back into Australia a few years ago, and I was a project manager on that. And I've managed to get on some really cool projects in autonomy, robotics, automation in Australia, weapons testing, which requires really high-end software and algorithms and that, all of those sorts of elements, which, although developed for defence, can pivot to other sectors, particularly space. And so I guess for me, I was quite lucky, probably in the right place at the right time, where I kept on getting these amazing opportunities to work on some amazing projects. And then all of a sudden, sort of 15 years disappeared. And then the Space Agency's born. And now we've actually got a thriving, driving, inspiring space sector. So people like me and students in this room, there's quite a few out there, if they choose, don't actually need to leave Australia now to pursue a career in space. And so I think I'm quite lucky in that my career path has been through the Australian industry, Australian defence, and now I'm here, deep in what we're working on in multiple different areas, which we'll touch on in a minute, in the space sector.
Yeah, fantastic. Now you mentioned the thriving space sector, so that's a really good lead-in to ask Matt, what inspired you to start a company and to start a space company in Australia?
I guess the reason I started the company really was because I really wanted to continue working in space, and as Sarah was mentioning, a while back, there wasn't a lot of industry working in there wasn't a lot of space industry around. So I kind of decided that if I wanted to continue working in the space industry, that I'd have to start a company myself to do it. So I guess my history, I guess when I was a student, I never really saw myself as starting my own company. I mean, I was an academic initially. I did a PhD as well. I did it in Europe, as we said. It was very difficult to do specific space stuff here in Australia. So I went to Europe, came back, and like Sarah, got into the defence industry and did a lot of weapons modelling and kind of got into the testing side of things. So you kind of I guess building the skill set, and my background was launch systems, so kind of got into rocket guidance systems. So I was sort of, I guess, pursuing that through a defence angle, continually trying to get projects up and running around the launch area, because that was kind of my expertise. And probably that was even up to 10 years ago. Australia had no appetite whatsoever for that kind of thing. So probably around 10 years ago, I sort of said, well, I'll change tack and kind of get into satellites. And around about the same sort of time, I was doing defence contracting and thought, well, why don't I go out on my own instead of contracting through a prime. So I started a sole trader and sort of started engaging with defence, and at the same time kind of trying to push this satellite side of things forward. And then I guess that just sort of really snowballed. So kind of looking back, it's kind of funny. You get one person and then another one and then another contract and another one. And eventually you turn around and look and there's 50 people behind you, which is kind of never, people ask me, what was your strategy? How did you plan it? I didn't really. It just sort of happened going forward. So it was, it's really great now that, when I left uni, there was virtually nothing in industry that you could do from a space perspective. As we mentioned, defence and CSIRO have been heavily involved for a long time, but on an industry side you had to really go overseas. But with the change, with the space agency coming online and in all the agency, I think CSIRO has also become even more space focused since the agencies arrived, as has Bureau of Meteorology, as has Geoscience Australia. So all the sort of the government is also becoming a lot more engaged. So I guess that sort of that momentum, I suppose, has sort of spurred me on to kind of continue growing the business, and I think I made the right decision at the time.
Yeah, I would agree. So that's a really fantastic foundation for where we'll be going for the rest of the evening. So thanks for those setting the stage there. So we'll get a little bit more specific now. So most of our audience is likely aware of the value of Earth observation. Can you tell us about some of the work that each of you are doing in that particular sector? And Kimberley, we'll start again with you.
Sure. So our use of Earth observation in CSIRO is quite broad, obviously because we have such a wide range of science areas in the organisation. We have scope to apply the benefits of satellite technology to a really wide range of areas. So data from satellites, we can use to help grow our major national industries from creating applications that help improve the productivity of the agricultural sector, to identifying fugitive emissions from mining sites, to helping to monitor and respond to natural disasters, for example. Some of the things that we do within CSIRO, we operate national facilities, and one of the facilities that we operate is the Novasar-1 satellite, which is actually a UK owned and operated satellite, but we own 10% of that satellite, and we're able to task that satellite to look at specific areas that we are interested in over Australia, and we make that capability available to Australian researchers and companies to request the use of. And this satellite is a synthetic aperture radar, which means that it is able to look through smoke and clouds and darkness. And so it is an excellent system for being able to monitor things through like bushfires and cyclones and so on. So that's one of the facilities we offer. We also do a lot of work around data analytics and developing very high-end data analytics platforms. So basically software that people can use to help with the analysis of the very, very large volumes of data that we get from satellites. It's really an enormous volume. It's growing all the time. And you essentially need supercomputing power to be able to utilise a lot of it. Most people obviously don't have access to that. So we create this data analytics platform that enables people to access data from satellites more easily in a form that's a lot more usable, so they can immediately realise the benefits to their company or their research or so on.
Fantastic. Excellent. Thanks. Sarah, how about you?
Yeah, so Kim's kind of covered, that very broad range of what we can do with Earth observations, so observing the Earth from space. Specifically at the SmartSat Cooperative Research Centre, not many people know what a CRC is, but we're essentially a research organisation which brings together industry and academia to collaborate together on projects. One of the projects that we're working on is called Cannard, so it's the South Australian Services Mission. There's some stickers and some brochures out the front if you didn't get a chance to pick one up. But Cannard is about pulling together South Australian service providers and hardware, so Innovor and Matt are heavily involved in that. Another company, Myriota, who do Internet of Things, they're also involved in the SmartSat CRC. And this is a small satellite, but it's going to be fitted out with some really high-end, what's called hyperspectral capabilities. So that means it can look at in multiple spectral bands, and different spectral bands can be used to measure different things, depending on whether you're looking for rehabilitation of mine sites, so you're looking for the foliage, or it could be looking at water, coastal water, or bushfires. So all of the applications that Kimberley's mentioned, some of those we can measure with this South Australian satellite, which will be going up in a couple of years. And that'll be in space for 3 years, and we'll be able to use that data to help us understand water quality, inland, coastal, land rehabilitation. And that's just, I guess, a capability demonstrator, which means it's to prove that we can do this, and it shows government and society what we can do with that Earth observation with just one satellite. So the capabilities are quite powerful, and so that's going to be South Australia's first homegrown satellite, and so it's certainly something to watch out for, and we're really excited about what we're going to be able to find from this satellite.
Excellent. Matt?
So Innovor Works kind of, we're quite exposed to the Earth observation industry, and we kind of operate in two ways. So we kind of, first of all, we build missions for other people, and then we have 2 missions of our own. So I'll just explain a little about building other people's missions. So we focus on the small satellite. So this is actually a model of Cannard, and that's 1-to-1 scale. So that's how big the satellite is. And typically when you're building a satellite like that, you would go, what would normally happen at universities and lots of commercial companies, you go and find the parts that you want from a whole lot of suppliers around the world, you bring them together, you plug them in, and you basically build the satellite like that. And so we did that once. It was 2016 that satellite launched, and it was less than successful, and it was really around the ability to test the system. You're kind of buying a whole lot of black boxes, you plug them together, and then you feed some information in and something comes out, but you have no idea what it's doing inside or why it's doing it, or if you're close to an edge case or anything like that. So the ability to test and understand the system is really quite degraded when you do it like that. So we made the decision to completely vertically integrate and design and build all of the subsystems inside the satellite ourselves. So that's the pointing system, star trackers, reaction wheels, the attitude control system, all the algorithms that work out which way the spacecraft's pointing and how to change the direction it's pointing, all the power systems, its batteries, solar chargers, solar panels, command and data handling, so all the software that runs on the satellite, the ability to send tasking up to a satellite and interface with it. So all those systems we decided to make ourselves. So then we kind of had this technology or base set of technology that we could use to fly other people's missions. So that's when we go to our customers and say, well, we got this stuff, what would you like to put in space? So Cannard comes along and says we want to put a hyperspectral imager. So we take our technology, we take their hyperspectral imager and Myriota's Internet of Things payload, we put them together, and then we build the spacecraft, and then we do all the testing, and we support mission operations. So because we know what to say to the satellite, we're in a very good position to be able to task the satellite and talk to it. So I guess that's our involvement in what Sarah was talking about on the Cannard mission. So we're essentially the manufacturer of the spacecraft, and then we're going to support operations going forward. And we have a couple of other missions where we're doing that. We're building one for the Department of Defence that's got an HF radar system on it, as well as an optical communications terminal. So some of these technologies require very specific attributes. For example, the Myriota Internet of Things payload is very, very sensitive to noise, so that the satellite platform has to be extremely quiet, and I'm talking about in radio frequency emissions quiet, in order for the system to work. And then in the DST group mission, we kind of got to point a optical comms terminal, so it's essentially pointing a laser at a dish on the ground and being able to communicate with it. So that's got very, very tight tolerances to be able to point down. So those there are a couple of other areas where we kind of work in the delivery of platforms to support Earth observation missions for other people. In addition to that, we have 2 missions of our own. One is looking away from Earth, and I won't talk too much about it, but essentially we have a long relationship with the AIML, Adelaide Uni Institute.
Institute for Machine Learning.
Thank you, Australian Institute for Machine Learning. Sorry, TJ, if you're here, I didn't get that right. So that's where we're kind of looking away from Earth, looking at space objects and debris and all those sorts of things. But because you have this platform, and this platform essentially is an imager, it's almost entirely an imager in the satellite, and all the parts are built around it, like the batteries, the reaction wheels, all kind of fit around in the package. So it's this really tightly packaged telescope with a whole lot of electronics packaged around it, and it's got an onboard processor unit, which means you can do this edge compute onboard the satellite. So what does that mean for us in our Earth observation? So we then decided, well, we'll make our own mission where you're looking down, and instead of just doing point and shoot, like if you want to have an image of your backyard or your neighbor's backyard, you give me a credit card, I'll take the required amount of money, take an image of the backyard of your neighbor, and then send you the image. That's kind of how traditional Earth observation works. And it's, I guess, a very mature market's been doing that for, 50, 60 years or a long period of time. But I guess the thing that we're doing is, instead of just point and shoot, we're looking at trying to find things that you don't know exist. So, for example, and we've had 2 contracts with the Office of National Intelligence. Obviously, they are looking for different types of things, but you can imagine the spacecrafts flying along, surveilling the ocean, maritime region around Australia, looking at images saying, this waves, 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 boat. Take an image of the boat, say, I saw this boat, this is where I was, and then keep looking, and then there's a runway in the ocean. It's a bit weird, image that, look what I found. And then also, like in jungle, so flying across jungle and looking for things that are not, essentially we're looking for things that are man-made objects or not natural objects. So we've developed a machine learning algorithm that can detect, without any background knowledge, can detect if something is a man-made regular object or if it's a natural object. So we're kind of getting into this, I guess, more a surveillance type application. And that's sort of, I guess, where we're heading in our own application in regards to Earth observation.
All right, really, really interesting. I'm going to come back to Kimberley. You mentioned that CSIRO has all this data coming in, and you spent quite a bit of effort to make that data usable and accessible to the public. So that brings to mind a potential specific application. So on the 22nd of March was UN World Water Day, as you know, which celebrates water and raises awareness of the 2 billion people still living without access to safe water. Can you tell us a bit more about CSIRO's AquaWatch Australia and what the challenges it faces and what it will achieve and the benefits it will bring?
Thank you. Yes, so you may have seen in the news on Wednesday, World Water Day, CSIRO launched a new mission called AquaWatch Australia. And I know the terminology is a little bit confusing because when I say launch, I mean basically announce, not fire a rocket into space. And when I say mission in this context, I don't mean a space mission, I mean a very large program of R&D activity. It's called AquaWatch Australia. And I guess one of the things that I didn't really talk about so much previously was how terrific Earth observation is for monitoring the environment. Particularly in Australia, we have a very large landmass, it's very sparsely populated. Satellite imagery is one of the best ways that we have of being able to achieve information across the whole landmass on a regular basis quite quickly. We just wouldn't be able to do it all from the ground or even from the air the way that we can from space. So AquaWatch Australia is planning to establish a national network for the purpose of monitoring the quality of fresh water and coastal waters across Australia. And this, of course, will eventually have applications globally as well. It's obviously a massive issue internationally. What the mission consists of is a combination of ground-based sensors or in situ sensors. A lot of them will be little sensors that actually sit on the surface of the water and can measure the water colour, which from the water colour you can actually determine a lot of information about what's going on in the water. There will also be satellite imagery, which we connect with the ground-based information and bring that together with modelling and data processing to be able to forecast water quality across the country. And so if we can do that, then people who manage our water systems and people who rely on the water for their businesses and for their communities will have a much better opportunity to act on information that's likely to impact their accessibility to that water and the safety of that water. So for instance, you might be able to get advance warning that a blue-green algae bloom is about to occur. And so using that information, you can combine that with, if you're a water utility, your dam levels and whether you should release a water flow or something like that to best manage that situation for the optimal outcomes. It's very topical. I'm sure you've seen in the news in the last few days the Meningi fish kills. Being able to assess water quality is really important, and at the moment we have plenty of information that monitors water quantity, flow rate, how much water we have in dams and rivers and so on, but not the quality of that water. And so we're going to bring that information together into a single system, like I said, where we can forecast water quality. We hope to have a demonstrator system operating by 2026. And ultimately, we would really like it to incorporate Australian-designed satellites that have been built specifically for this purpose. At the moment, we'd be using data that comes from international Earth observation satellites. We certainly can use that to establish the system, but those systems are not typically optimised for the conditions in Australia. So, for example, in a lot of places in Europe and the US, you would see very big lakes, for example, inland. Australia doesn't have a lot of big lakes. We have a lot of long, skinny rivers. And so the resolution of the satellites is not really quite optimal for what we'd like it to do. But yes, we will begin with that and work towards a really finely tuned system for Australia.
So a unique country that requires unique solutions from Australians.
Absolutely.
Yeah. Matt?
So I guess I just thought worthwhile talking a little about the technology behind that. I think you kind of, people probably have this impression that, defence have these super tight requirements and the systems need to be like these exquisite systems. It's actually the reverse. So if you have a look at what we're doing, you just need an image, it can detect shape, exactly what spectral frequency is being reflected and all these sorts of things is not that important. But when you're doing a mission like what Kimberley's talking about, your sensor has to be so strictly calibrated as to what spectral band you're looking for. You've got this algal bloom, it might only have a very narrow spectral response, and you need to be able to pick that up, and you also need to know exactly how many photons in that spectral band hit the sensor as well. So not only are you looking at spatial resolution, you're looking at spectral resolution and radiometric resolution. So the scientific kind of instruments are extremely difficult to build, and I know CSIRO have been working on them. In fact, in this building, they're already building sort of really interesting sensors and detectors and those sorts of things to try and solve that problem. So it's actually quite. It's obviously from industry's perspective, it's an extremely interesting project, and we're very glad to hear that CSIRO want to have an Australian-built satellite and sensor, which is great. But just it's actually a really difficult problem. It's not just a case of get a GoPro and take a photo from it, because that's a lot of people do that. I mean, you can put a GoPro in space. We could put a cheap imager on a satellite and collect images of car parks and be able to detect all sorts of things. That's really interesting. But when you need to get the radiometric and spectral resolution accuracies, it's actually a really very, very difficult and complex mission to build.
Can I also just add, there's actually some flyers out the front about AquaWatch, and they are courtesy of SmartSat. I just wanted to highlight that SmartSat is actually our CSIRO's foundation partner on the AquaWatch Australia mission.
Yeah, great. So please pick those up on your way out. This has been a really big week for space in Australia. One notable event out of many that occurred this week was the visit of the NASA Administrator, Senator Bill Nelson, and the Deputy Administrator, Colonel Pamela Milroy. And while they were here, they visited a number of different places and gave a number of talks. And at those, they mentioned the Artemis program in quite a lot of detail. Now, while I would expect most people in the room know what the Artemis program is about, in case you don't, the Artemis program is an international effort between NASA and its many partner space agencies. And it's the first step in the next era of human space exploration with the specific goal of returning humans to the moon, this time to stay. So necessarily, unlike the Apollo missions, which were short-stay sorties, the Artemis program aims to return time and time again to the same location for the express purpose of aggregating infrastructure, which will then slowly increase the capabilities of that particular research facility. So what I'd like to ask everyone here is, can you tell us a little bit about what you might be doing that would support Australia as a member of the Artemis program? And Sarah, we'll start with you this time.
Yeah, thanks, John. So it has been a very exciting week. One of the announcements that we had on Monday was the announcement of 2 consortiums who are going to design, build and operate a lunar rover on the moon for NASA, so for a NASA mission. So this mission is all about understanding whether or not we can take the lunar regolith, which is the lunar dirt, and put that through, a scientific facility and extract oxygen. And I won't go into the details on why that's important, but obviously, there's some elements there that we need to survive. So the Trailblazer rover it's going to be a very small thing. We've got about 20 kilos that NASA are going to take to the moon for Australia. And so we're talking kind of microwave-sized rovers. So a lot of the rovers that have gone up lately, Perseverance is the size of a ute. Viper is about the same size as well. So we're talking very small. But the purpose of this rover is that gets deployed on the moon. It'll roll off the lander. And what it's going to do is it's going to collect small amounts of regolith, but multiple times. And it's going to go out from the lander, pick up some regolith and return it to this in situ resource utilisation facility, where NASA's then going to try and extract the oxygen from that regolith. And our job is to design and build that rover. So the 2 consortiums have been selected to, go through a design process over the next 15 months or so. And those consortia, one of them is AROSE, which is Australian Remote Operations for Space and Earth. And under them, Nova Systems, which is the company that I work for. It's an Australian-owned and operated systems engineering company. And Fugro, who is based over in Western Australia, are managing the project and also going to provide the remote operations element to it. The other consortium is a company called EPE, who do electronics. They're based over in, they do robotics. They're based over in Queensland, and they're partnering with Lunar Outpost, which is an American company who have a lot of experience with lunar rovers. So it's a bit of a friendly competition with regards to which one of those consortiums will be chosen at the end of the 12 months to actually go into production, manufacturing, integration, testing, with the aim of launching at around about 2026, but I think it's probably going to be delayed given the significant delays and the complexities of the system. So it is a really exciting time for Australia. We had Australia's first female astronaut to be trained as an astronaut announced about a fortnight ago. This week we've got a lunar rover I mean, if you're not excited about getting into space now, they're the two most exciting things that you could possibly do in space, apart from finding intelligent life. You know, this is really, really amazing. And the length of these programs is that if you're, you know, at university, or if you're in, you know, year 11 and 12 and you're looking to get into space, by the time you graduate, or even, you know, doing interns and work experience, you can actually get onto the programs, you know, with myself under our consortium or under the EPE consortium, and actually work on developing a lunar rover for NASA, which Australia is going to build and operate. And it's just, it's a really exciting, amazing, challenging, scary time for Australia.
Awesome. Yeah. Matt, can
So-
you follow that up?
Yeah, not that well, I'm sure. So I guess, you know, as industry, you look at, you know, we're a satellite manufacturer, and this is a rover. So, you know, we don't actually build rovers, but come on, I mean, a rover on the moon, again, one of the most exciting things I think, you know, we could be doing. So we obviously jumped at the opportunity to try and get involved. And I guess this is where I think we have the advantage that because we made the decision to build the subsystems ourselves, we understand exactly how to build these systems. I mean, we selected and in many cases actually placed every single electronic component on the boards, written every line of software. So we're kind of in a good position to build something new. So we're actually we are in the EPE consortium and hopefully the AROSE one as well. We also have had a discussion with them beforehand. So I mean, as industry, we basically said to everybody who's playing, you know, we really want to just be on a team. We're not going to prime it. We're not going to lead it. We know we're good at a couple of things, and we could certainly contribute to it. So we basically, you know, went to 4 different teams and said, you know, we'd really like to be on your team. And EP was obviously announced as that's one of the teams we were on. And I can't really talk about the specifics of what we plan to be doing in that instance, but I think it's to do with the navigation side of things. So trying to work out where you are on the moon. And that's obviously you don't have GPS satellites around the moon. So you kind of have to do it other novel ways, and also potentially on the power system side. So again, you know, while it's not specifically in the area that we operate, or, you know, we kind of in the observation type satellites is sort of what we usually do. This is such a great opportunity to do something slightly different, and on one of the most exciting missions, you know, since the 60s when they originally went to the moon. So we're super excited about it, and really looking forward to, you know, kind of taking the next step, building something, and then obviously to have something, even if it's something tiny on the moon that we built, is obviously a buzz for the team. So it's a really exciting time for us as well, and yeah, we're looking forward to the next 15 months to see what we get to be able to do out of this.
Awesome. Kimberley, how might CSIRO be involved in supporting this as well?
So we're actually looking at supporting Artemis and generally lunar exploration in a couple of ways. First of all, we are growing our capabilities and facilities to support Australian industry as this Trailblazer mission goes forward. A bit over 12 months ago, we opened a new facility in Queensland, which is our in situ resource utilisation facility. It's essentially a lunar testbed, and it has an adjacent control centre, and it contains a large amount of lunar regolith simulant. So we can test robots there. We can test remote operation of these vehicles on the lunar surface. We have dust boxes with some very fine regolith simulant in it, where we can test how mechanical systems respond in that dust and so on. So we're doing quite a lot of research into that area. We also have some projects looking at material coatings that can mitigate against the lunar dust, for example, because this is one of the biggest challenges facing activities on the lunar surface. The dust is terrible, it's extremely abrasive, it sticks to everything, it gets into everything, it will ruin your mechanisms very quickly. You certainly don't want to get it in your spacesuits or your space vehicles at all. So that's a really big challenge that we're hoping we can contribute to. And it's not something that they've solved at all since Apollo. It is an ongoing issue. Also, one of the things that I probably should have mentioned right at the very beginning is that you may be aware that CSIRO works very closely with NASA and also with ESA, supporting deep space communications for spacecraft. The Canberra Deep Space Communication Complex supports on the order of 30 deep spacecraft at any given time. It's part of NASA's Deep Space Network. We also have a deep space tracking station for ESA that we support in Western Australia. And you've probably all heard of the Parkes radio astronomy antenna, also called Murray-Yang, which supported the Apollo 11 lunar landing. What we're looking to do is to use some of our radio astronomy antennas to actually support commercial lunar communications for the Artemis CLIPS providers, so the commercial lunar payload service. Thank you. Yes. So these are companies who have been contracted to NASA under Artemis to take things to the moon for them. And so, of course, they're all going to need their own communication systems as well. So that is something that we're doing too.
That's all very exciting, and I know it's just really the tip of the iceberg of everything that Australia is doing that would be applicable to the Artemis program. But I want to go back to something Sarah mentioned. So you mentioned students a bit ago. Now, I think it's fair to say that space interests and excites people of all ages, but probably university students or students that are still in secondary school are probably at a unique have a unique opportunity here with regard to selecting, thinking about a future major or future career in space. So I wanted to ask each of you, because I think we have a few students that might be in the audience tonight. What areas of technology development is Australia working on right now that you think might be particularly relevant to space? And you've mentioned some of those, but can you talk to us a little bit about where some of those areas are going to have the most impact in the space sector of the future?
Yeah, so space encompasses so many different areas. It's hard to say, let's focus on lunar comms, or let's focus on quantum computing, or let's focus on remote operations. There really is so much out there that we could work on. I would be hesitant to suggest even, top 5. There's 20, 30, 40, 50 technologies out there. But I think if you're a student and you're looking to get into space, engineering teaches you how to research, and it teaches you how to understand problems, and it teaches you methodologies on how to come up with solutions. So I don't think I've used any of my specific learnings from my engineering degree, like I don't know, like the Bernoulli's equation anymore. I don't even know how to do long division, but it's like, that's beside the point. The point is, if I ever needed to understand what that is, or some new equation, or some new type of technology, I've got the foundation and the confidence and the skills to go and understand that problem, find a solution, or develop a new solution, integrate parts to create a solution. And so, honestly, I think students these days, particularly young students, some of the technologies they'll be working on probably don't exist, or if they do, it's in a lab and maybe there's one prototype in one company around the world, or it's hidden in DST or in DARPA or in NASA. And so I think it's just find that, if those students find that passion, it could be robotics, it could be programming, it could be project management, it could be law, it doesn't even have to be engineering, then there's going to be an opportunity for them to undertake that career in the space field in Australia, or literally almost anywhere in the world.
Yeah, great. Matt,
So, I mean, I would echo that. I think, space is very exciting, but it's not special. It obeys exactly the same fundamental physics, chemistry as everything else in the world. And I think, Australian universities do a great job educating our grads. We have, we're obviously in a fairly exciting area, and so when we kind of have job applications or interns, we have a lot of applicants. There are a lot of people that are interested in coming to join us, but the caliber of the people that we have is just mind-blowing, better than I was by a long way, right? So I think, the universities do a great job in educating people in what they need to know as fundamentals, but also, as Sarah said, it's not really about knowing a particular equation or something, it's about knowing how to find out how to solve a problem. It's really, and that's the sort of things that you get taught in a broad range of things, from engineering through sciences, physics, anything, even solving policy problems, in areas like that. So, I think we're really lucky in this country that, while we don't have the depth, we haven't got the people who've been working in the space industry for 60 years or 40 years, 50 years, whatever. And we do have a really strong cohort, I guess, of young people coming into the industry. And I mean, our company is probably quite a good example of that. So, we don't typically bring in people external to be the senior people in our company. We've typically grown people from the beginning. So all the senior management group, or the technical leadership and the architecture leads are all people that have been in the company for a long, long time and have kind of grown into it. So, I think everybody in the industry is having to do that, because it's just that there are a couple of expats coming back from international to kind of, get into these companies. But I think, it's so much young people kind of coming into the company and growing with the company and learning all the skills that they need. So I think, what you've got to do if you're interested in space, and no matter what part of space you're interested in, you're probably in the right place right now. And not only this university, the universities all around Australia are just fantastic. I mean, this is specifically a good university, but we have people from all across Australia, and I think it's a great opportunity at the moment. So if you're interested in it, the opportunities are there for you, and you could be building something that goes to the moon or to Mars, or you could also be, building the next high-tech kind of piece of technology. I'll just touch on one interesting piece of technology that has been developed here by Quantex. I don't know if anyone heard of Quantex Labs. They're a company that came out of Adelaide Uni, building very, very high-precision clocks. So the application here, one of the applications in navigation. So a GPS, for example, GPS satellite has an atomic clock in it, so it flies around and it knows down to 100 millionths of a second exactly what the time is, and and having that accuracy enables it to tell you where you are on the ground. So these clocks that are being developed just across the road and here are kind of 2 or 3 orders of magnitude better than those. So they kind of, I can't remember I'll get the statistic wrong, but it's something like it loses 1 second in 14 million years or something like that. So you can imagine this is the most accurate timepiece you can kind of imagine. So this is really novel technology, and it's better than anything else in the world, and it's basically made right here in South Australia. So I think there are a number of them around there. There's lots in the electronic warfare space. There are lots of really novel technologies in defence being developed. So I think we have every opportunity globally to basically be world leaders in space in a number of different areas.
Thanks. So Matt mentioned some things happening in South Australia. Kimberley, what might be happening at the national level?
Well, I was having a think about, what things might look like in another 20 years or so, and what some key drivers would be for the space sector in that time. And first of all, pressures on our environment, demand for clean water and food, will drive just exponentially growing demand for the information that we can get from Earth observation. That's always going to be a massive ongoing need. Regional, international, national security is going to continue to be an issue, and also the security and the sustainability of our space environment. One of the things we haven't touched on here tonight, I guess, is space situational awareness and being able to track what's in space, removing space debris or at least keeping track of it. How can we design our space missions to be more sustainable into the future? Another real challenge is going to be around data. Already, we're so bandwidth limited in how much data we can bring down from space. Every time an instrument gets better, has better resolution, and that's what we want, or we have more overpasses, we have bigger constellations of satellites. But you've still got to get all that data back down to Earth before you can use it, and we're ending up with a massive traffic jam of data. So finding ways to ease that, whether it's through onboard processing techniques so that you end up compressing the data before you send it down. I think Matt talked a little bit about intelligent onboard data gathering. So the satellite is doing some of the thinking about choosing what it's going to image before it sends you that information. Better ways of communicating with satellites at CSIRO. One of the things we're doing is taking some of the technology that we developed specifically for our radio astronomy, the phased array technology, and applying that to ground stations to communicate with satellites. Because at the moment, you have one ground station which at any given time can communicate with one satellite. And at the moment, we've got something like 8,000 satellites in orbit. So we can't go on having one ground station for one satellite. That number of satellites has doubled in the last 12 months. Right? So using the phased array technology means that we might be able to use one ground station to communicate with potentially 100 satellites simultaneously. And then using artificial intelligence and machine learning for better data processing of this enormous volume of data that we've got. So yeah, that's just a few things that come to mind for me. And just on a personal note, I also studied mechanical engineering, but after I did that, I studied space law and policy, which has sort of led me to where I am now. So yeah, I think Sarah mentioned there's plenty of engineering problems to be solved, but there are also other professions, other careers that we need in space too. Space is it's a unique operating environment, but all the jobs that are required for operating environments on Earth, we still need them for operating in space as well.
Yeah, that's a fantastic comment, especially for any students in the audience who, or professionals who may not be a scientist or engineer themselves. But that's one of the things that I think really brings a lot of advantage here at the University of Adelaide is that we include our School of Psychology, the School of Architecture, Humanities and Education in all of our space projects because exactly as you say, this is a human community off Earth. It's going to need all the same support that we need here. So we're looking into those questions and we need all of those skill sets to do that.
And that raises another area that I didn't mention just now, but the fact that Artemis, we're looking to have a permanent human presence on the moon. So far, we've sent a couple of people to the moon for a couple of days, and we've had people on the International Space Station only 300 kilometres away from Earth who can come back very promptly. There is still an awful lot of unanswered questions about how you support human life in space for a sustained period of time, well away from the Earth. Yeah. And that's work that Adelaide Uni is also doing and that CSIRO is doing a little bit of research into as well. Yeah.
I think to extend on that, the plants in space. So I know there's a big, John, you can fill everyone in on the details on this, but that's a major area. And apparently duckweed is the food of choice or the protein of choice, and it grows on the Torrens. So,
maybe we'd find a different source.
We might find a different source. So, plants in space, how do they grow? And Bill Nelson, so the NASA administrator last week, said that they've just been able to grow plants in lunar regolith. And that's a major milestone. So obviously it had, we added water and added nutrients, but the fact that I guess the building blocks, the physical soil, for the want of a better word, can sustain plant life is phenomenal if we could just bring those nutrients in. And that was regolith that the Apollo mission brought back. So they're making some major headways. But to have that permanent presence on there, we can't just be growing one lettuce every 6 months and a couple of bits of duckweed sausage, whatever that looks like.
Yep.
So it needs to be a real it's a logistics. The whole value chain, the whole supply chain needs to fit together in order to sustain that life.
Yeah, and there's a lot more other aspects to sustaining the life in space as well. So, for instance, your pharmaceuticals, even if you just wanted to take ibuprofen with you, it degrades in space really fast. If you're gone for more than a couple of months, what are you going to do when your painkillers don't work anymore? So one of the things they're looking at is how can we manufacture that in the microgravity environment? So rather than taking it with us, we make it there. We're also, one of the activities we're looking at is how we can better recycle carbon dioxide in closed systems. Because at the moment, mostly they extract carbon dioxide on the International Space Station, but they just jet it out the back. They don't actually use it for anything. It's not a proper closed cycle system. And if you're travelling that far away, you want to reuse as much of what you've got with you as you can. And then there are the other elements around actually what we call foundation services. When you actually get to the lunar surface, it's not just about driving our rover around. What else do you actually need to be able to build there to sustain a long-term presence? So shelters, landing pads, maybe we need roads that are a bit better than the rocky surface that's already there, and so on. So that's an area that we'll be looking into in the coming years as well.
Now, we did not coordinate this, but I'm just going to follow up on a couple of things here. First off, thank you for mentioning Plants for Space. That is an incredibly fantastic decision by Australia, already a leader globally in ag tech because of it's a unique country, as you mentioned before. But to make that investment, that'll be a center that will have 400 researchers looking at that problem of how do we provide solutions to space food and space pharmaceuticals and space materials, but then also return that technology to the Earth. And I'm going somewhere with this, and it'll be a question for you all here in a moment. As well, the ibuprofen example, University of Adelaide had 2 payloads on the International Space Station that had ibuprofen up there. One set of those pills that we made was kept inside the station, and one was exposed outside the station, specifically to measure that degradation. And finally, the foundation services. We have a lab built here at the University of Adelaide specifically to answer those questions broadly around civil engineering and how do you aggregate infrastructure and connect power cables and move water and other volatiles through cables. So we've got those kinds of labs here at the university. Now, the interesting thing about all of that research is there's an Earth return that we could benefit from, and that novelty is forced to be developed because of the efficiencies that we have to find when we move to space they're probably unique to that environment. Could you give any comment on that, Matt? How the efficiency is of trying to put that together?
Ad-libbing is always dangerous. But, I mean, I think there are all sorts of things that you have to consider when doing things in space. Like the environment is entirely different, and I guess because it's such a hostile environment, if you do things in space, you can actually improve how they would perform on Earth in a less radiation environment, or in a less. I mean, we're talking about the moon regolith being so aggressive on abrasion on everything. So if you can kind of operate there, then you can operate there for 5 years, or in 5 years you can probably operate here for 50 years, kind of thing. So there's a lot of things that I think we would learn so much. Doing the difficult things, you'd be able to learn so much to improve the things kind of down here on Earth. So I mean, we apply that. We don't have the lunar regolith problem, but we certainly have like radiation problems, and you have vacuum. I mean, grease, for example. You just think put a ball bearing on anything, or you want a wheel rolling. So our satellite's got reaction wheels, and of course you can't have grease in them because the grease evaporates very quickly because the pressure is 0. So anything that's remotely volatile sort of disappears, and then eventually you've got powder for a bearing, which is not fantastic from a lubricant perspective. So I think there's so many things that we consider, but there are so many things when you kind of embark on something like Artemis that you don't know yet, which I think is kind of where the main advantage, and some person will come up with some great solution to solve a problem that we don't even know exists yet. So I think this ability to expand our knowledge and develop our technology is sort of so enhanced by doing something really difficult like this.
Fantastic, thanks. I have one more question before we go to the audience, and it's only because selfishly I want to highlight the Australian Rover Challenge that's outside. And you may have seen that on your way in. Just curious, show of hands, who here is involved in the Australian Rover Challenge? Do we have any participants and students? Awesome. Okay. And you can see some team jerseys and things out there. Great. Thanks for joining us tonight. So this is going to be a question I'm going to give to Sarah, so just so she has a little bit of forewarning. But you see the operations that are going on out there, and I saw you watching some of the teams today. Can you just make a comment about what an activity like that can do for Australia writ large, as it offers these sorts of skill sets to Artemis Program and then to commercial operations?
Yeah, so I think something that I've noticed sort of walking around this year, and I've been involved in the Rover Program for a number of years, is that I was having conversations with a few of the teams today, and they knew what I was talking about. And so I know that's come across not quite the way I wanted it, but when I talk to students in the past about how hard it is to integrate two bits of hardware, they'd be like, oh, yeah, I'll just take your word for it. But, you talk to the Rover team, they're like, integration is my biggest problem. I'm like, yes, now you understand, because they've had the opportunity to try it and get it wrong. And, so I think having them have this challenge, and it's a hard challenge, and, succeed or fail, although I never see an engineering failure as actually a failure. It's just a quick way to learn. Having that opportunity to actually hands-on tools, hands on the keyboards, understand the mechanics, the science, the engineering around a rover program, but also like the project management, the finances, the supply chains, the schedules, and how to convince those that are assessing your capability, so the judges, proving to us that what you're going to do is what we've asked you to do and haven't just gone off on a tangent. So there's just so many skills that they're learning, and they probably don't even know that they're learning half of them, that are going to be translated to their career once they graduate. I just think it's phenomenal, and you never really ever want to go back to school again, but I kind of do, to be able to have that opportunity that our little kids, middle-sized kids, and university-sized adults can have. Yeah.
Well, we appreciate that. We know you're extremely busy, and you've been spending a lot of weekends grading engineering reports on the rover. So thank you for that.
I'll throw something in as well if I can. I think when we look at recruiting people, you get a whole lot of grads come to you, and they've all got fantastic GPAs, and you kind of say, well, what distinguishes this person from the other one, or what differentiates you? And these are the key things that differentiate people. So kind of what else have you done? So sure, your grades are great, but all the things that you learn on these sorts of projects are so important. So when us as industry look at someone, same GPA, and one's been on a rover team and one hasn't, it's like an easy decision kind of thing. So I think it's definitely well worth your effort. I know there's a lot of effort for a lot of you. It's not easy what you're doing, and it's all extracurricular and that kind of thing, but I guarantee you it'll make a huge difference in your career.
Yep.
Fantastic. Thanks very much. So we have just a few minutes left, and what we'd like to do is take some questions from the audience. So if you have a question, please raise your hand, and a microphone will be brought over to you so that everyone in the room can hear your fantastic questions for our fantastic panelists.
Just a question for Matt, I think. Who is putting our satellites into orbit for us, please, Matt?
In the case of the satellites we're building, they're all being launched overseas, and in fact all in the US at the moment. So we actually have a small project with Southern Launch Ascension 80 space and us. We've got a payload on one of their rockets that's launching out of Whalers Way. So that's sort of, I guess, an opportunity or potential Australian launch service provider. But at the moment, it's all US.
This question is more directed towards Matt. So with the whole Artemis mission and putting humans on the lunar surface, would McWha be looking at setting up satellites to observe the lunar surface, but also potentially exploring outwards into exoplanets and their satellites?
Yeah, so I mean, we are, I mean, as a business, you're kind of looking at what opportunities are out there that you need to chase. So you kind of need direction. So government says this is the direction we're going, and you kind of chase it. So, you know, now that, you know, it's all moving, you know, forward, we kind of have a whole lot of different applications, proposals in for all different sorts of things. And some of them are moon-based orbiting systems. And some of them, I mean, the current system we have, Hyperion, is aimed at not only space domain awareness around Earth, but it's all the cislunar environment. So detecting any object, you know, we can detect an object about half the size of this banner at the moon, right? So we're looking at, you know, detecting any sorts of objects. So I think, you know, as with everything, we've got proposals to do all sorts of things, and some of them will come off and some of them won't. So, you know, and that will be basically the thing that governs whether we do or don't do it, is if somebody pays for us to do it, right? So yeah, we're kind of looking at all these sorts of things. You know, constellations around the moon there are more than 3 proposals already being considered for that.
Okay, so I think we have time for one more question, and there's someone right over here. Thank you.
Hi, I really enjoyed this talk. Just one question, I guess, for anyone. Are there benefits to shared infrastructure, or are there any principles around sustainability in space and making sure, or are there systems where it's like everything goes up must come down to ensure that, you know, celestial bodies aren't harmed and we're not necessarily changing atmospheres like we've done on Earth in climate change and all of that regard?
So yes, there is a short answer. So space sustainability is a major topic, and that's everything from the regulatory side of things. You know, should we mandate that satellites that are orbiting the Earth and maybe, you know, the Moon must be brought down in a controlled manner so it's not space junk? Who's policing that, and how can we really hold them to account? There's also, you know, the lunar rover. We're not going to go and bring that back, right? And is that a bad thing, or is it a good thing? Is it space junk, or is it space heritage? You know, it becomes history. You could imagine if we said, oh, we're going to go and bring back the Apollo 11 landing site because it's junk. So I think there's where we're at now with regards to having these conversations. These, you know, rovers on the moon, lots of satellites in space is really starting to, I guess, help ground that conversation and start that conversation more seriously. And so I don't have a solution. I'm sure Matt and Kim can probably talk more authoritatively about it. But I think having the conversation and having the courage to ask those questions about sustainability and are we doing this, you know, in the right way. And I know, you know, Nick can probably, you know, talk about going to space. I can't remember what the tagline is, Nick, but going to space in the right way. So making sure we do it from the start sustainably, but it's not just about space junk, it's about the respect for those, you know, Indigenous cultures that use the sky. You know, and if we're putting up 6,000 satellites that have a lux of, you know, 6 or whatever the value is, you know, we're going to be changing the way the constellations look. And is that pollution or is it science? So I don't have the answers, but it's certainly something that we're continuing to investigate and try to understand without crippling and putting, you know, the whole space endeavour on hold. So I know it's pretty wishy-washy, but we are working on it. Certainly at the top of our list of things that we need to consider to make sure we do space right.
I would add that our space agency is really forward-leaning on that aspect to it. I think, historically, when they put things up, they didn't even consider that, right? So many of the spacefaring nations still have that in their principles, as it doesn't matter. The Australian Space Agency started from the beginning saying, okay, this is a major concern for us, and how do we build the program going forward, kind of considering that. So, I would say that we're probably leaders in considering that side of things. I mean, when we launch something, most countries, you can launch it and that's the end of it. Our space agency wants to know what's its end of life plan, what are you gonna do with it, when's it gonna come back, all these sorts of things. So they kind of pushing the bar very high. Thanks, Nick. Pushing the bar really high for us when we're kind of putting a mission together. But of course, it's in everyone's interest that that's the case. So we obviously strongly support them having that stance.
And so that'll bring us to the end. But I'll just comment that. And that's the reason Australia needs to be part of this, is because you have an influence when you're part of that conversation and you're part of the program. So that's a fantastic note to end on. Please, can I get a round of applause for this fantastic panel of speakers? So that concludes the first installment of this 2023 speaker series. Thank you very much for spending your Friday night with us, and we look forward to having you back for the next one. Thank you.